Hi everyone, it's Mrs. Moore. Just wanted to check in, see how everyone's doing, and we are going to complete another page in your packet. So go ahead and get your packet out. We're going to complete this Chapter 6, Kinetic and Potential Energy and Energy Conversion page. All right, so once you have that pulled up, all you will need is a pencil today. In your Google Classroom, I posted an image with this. I thought I made a video, and I didn't. But I posted a fun video to watch. It's like a little song that will help you remember the difference between kinetic and potential energy. And then I posted also a Google Doc with this image in it. So you should be able to see this in your Google Classroom page. If you cannot see it, make sure you're letting me know. Comment below. This image really helps me complete this worksheet. I am a visual learner. I need to see things to help me understand. So let's review a couple things before we get started. Kinetic energy is energy of motion, and potential energy is energy stored, energy that is not moving. Okay, so let's look again at this picture. You can see it. So our potential energy is high right here. Our kinetic energy is low. Our potential energy is high because imagine yourself on a roller coaster. You are at the top of that hill. You are not moving, not yet at least. Okay, you might have moved to get up there, but then they always let you hang there for a couple seconds waiting to drop. Your potential energy is really high at that moment. You're not moving, but it's getting stored up, just ready to release, okay? So that's why our potential energy is high when you're up at the top. Now, if you're not moving, that means our kinetic energy has to be low. So whenever we have a high potential energy, we also have a low kinetic energy. They kind of go hand in hand, okay? So up top on this roller coaster, potential energy is high, our kinetic energy is low. Once we are released and they drop you down that roller coaster, your potential energy turns into kinetic energy. You are moving, you are going very fast. All that energy that was stored up was released. So your kinetic energy is extremely high in some cases. It's very high. If your kinetic energy is high, that also must mean your potential energy is low because you are moving, okay? So now let's get back to this worksheet with this picture in mind. If you want to keep this image pulled up, I'm going to be referring to it in a couple of the problems. It helps me when I did this worksheet before I recorded this video. So I would just have it pulled up on your computer, ready to go. So let's get started. Now, if you look at example number 1, I'm not quite sure what that's supposed to be a picture of. It's like some little beads or something right here. Think about our roller coaster. Where would our potential energy be at its highest point? Right, at the top. So we're just going to draw an arrow at the top. And we have high potential energy there. Or high PE, you can abbreviate. I know how much you guys all love writing stuff out. Okay, so if we have a high potential energy at the top, we must have a low kinetic energy, right? If we're right at the top, right here, think about that roller coaster. All that energy is being stored up, so our high potential energy, low kinetic. As soon as we drop, as soon as those beads or whatever those are in the picture go down, that's when it's going to change from a low potential energy and a high kinetic energy. Okay, so that's number 1. Let's go skip right down below it. Let's go to number 3, diving board. This is very easy for a lot of us to visualize. You're at the top of that diving board. Usually you're kind of looking down being like, what am I doing? Okay, you're not moving when you're at the top. Right before you jump, you're at the high dive, okay? Our high potential energy. We're not moving. It's getting stored up, ready to cannonball into that pool. So we're going to have very high PE, which also means we have a low kinetic energy. We're not moving quite yet. That little guy's just waiting, ready to jump. Now, once we do jump, we are moving. So our kinetic energy is at a high, okay? And that means our potential energy is at a low. So once we kind of jump in, we're moving. You know, you always dive into the water and you go to the top and you come right up to the bottom, or come back to the top of the water. So your potential energy is low, kinetic energy high. Number 5. Looks like a bow and arrow of some type. Think about when you're holding that bow, it's not moving. You're holding it nice and steady, focusing it on the target. So when it is in that holding position, it's going to have a high potential energy. If there's a high potential energy, that also must mean there's a low kinetic energy. So I drew my arrow kind of right to the tip of that. I'm sure you could draw it anywhere on here and it would be fine. Okay, but once that arrow is released, it is moving. All of that energy is being transferred. Okay, so it's going to have a very high kinetic energy and a very low potential energy. I want you to go ahead and try number 2 and number 4 by yourself. Okay? Once you are done with that, we can keep moving. Okay, now that you have numbers 2 and 4 complete, we're going to move on to the next numbers 6 and 7. Number 6 says, a book sliding across the desk comes to a rest. It feels slightly warm. What happened in terms of energy changes? So if it was sliding across the desk, it must have been moving. So it had a high kinetic energy. And then if it was stopped, it then had potential energy. So then a high potential energy. So the book moves from high kinetic energy to high potential energy. All right, number 7. Joe has twice the body mass as Sam. Sam is moving twice as fast as Joe. Is the kinetic energy of Joe less than, equal to, or greater than Sam? Explain your answer. Hint, look for the equation of kinetic energy. And I have listed the equation for kinetic energy. So I want you to try that one on your own. Good luck!